Here is the 3 questions animation that you can find as a link from your text. I'd like to go over at least one of these questions, and it would take these in reverse order here. Each one of the boxes on the left is a question that we answer with a research study. And each of these questions gets their answer from a specific part of the study that you read about. And they are pretty much independent. They don't really speak to one of the other questions at all, and that's one of the sources of confusion is in interpreting a study, is that people get a sort of generalize that the study is a good study or a bad study when it may have a very specific flaw that lends some limitations to what you can conclude. Doesn't necessarily make it a bad study. What I want to talk about first is the section on statistics. What do statistics actually tell us? And the question that they address on here is this third item: is the effect real or could it be a fluke? So after you get your data and you see that the measurements that you've taken from your experimental and control groups are as different, that the means are different, you want to know if that represents a genuine difference or if that's just a measurement error. And the way that you find out is to do the statistical analysis. And of course there are many types of statistics that are used, and each of which they fall into a category of inferential statistics, and they give you an associated probability value which will tell you if that particular statistic is significant. And so this is our measure. If the probability P is less than 0.05, that is 5 out of 100, the chances are very small that the difference that we saw between the groups was a fluke, and so it's much more likely to be a real effect. If the probability value or p-value is larger than 0.05, then we say that it's more likely due to chance, or it is a fluke. Now let's move over to the other screen. And I will show you an example here of what is research. We pose the question, we've gathered data in a systematic way, we've gotten our sample, assigned our subjects to groups, and collected our data. Then we analyze the data by using one of our inferential statistics. And then the question is, how do we tell if it's significant, and what does that mean? What we have is that for the purposes of this course, you have one of 3 different possibilities that will tell you if a particular statistic is significant. And since many cases we're looking at abstracts only, if the authors state that a finding is significant, that we assume that they're correct, that they use that term appropriately, that the peer review process worked, and that they actually have the numbers that back that up in their study. So if we had the complete data there, a complete study listed out, that we would be able to see that. However, in most of our cases, we'll actually have the statistical information. They'll provide that, and they may provide this p-value, and that p-value is a probability from a number of different statistics that can calculate that probability value, but the interpretation is exactly the same. So if the probability value that's stated is less than 0.05, we say that that is significant. The third type of decisive method that we have is a convenient factor that turns up only in the cases of odds ratios or relative risk ratios. And the confidence intervals around those particular ratios give us an indication of whether or not that value of the odds ratio or relative risk is significant. And that's uniquely because each of these ratios means that it puts the experimental and the control groups into a ratio, with one being in the numerator and the other in the denominator. So if the 2 groups are the same, then we know that that ratio is going to be equal to 1. So anytime you have that statistic, the closer the odds ratio or the relative risk is to 1, the less likely that the groups are actually different. And so when a confidence interval is calculated around those variables, as you can see here, you can see at the very top that there is a range of possibilities, with the 1 being in the middle and larger because that's our null value, or 0. And each of the blue lines below there represent a range of the confidence intervals that may be put out. And you can see that the first one down here is a -6 or a -6 to 0.5. And that means that the confidence interval, as stated, was -6 to 0.50. And the whole range that is for that particular measure, the confidence interval at 95% was between those two limits. And since the value of 1 is not in that range, then we say that that particular confidence interval, the statistic, was significant, because we can be 95% confident that the true value is not 1. The same is true with the second one down there, the -3.1 to a 0.5, because none of those values, that value is entirely below 1. The ones to the right, the 3 to 8 range, is of course completely above 1, and so we can again be 95% confident that the true statistic is not 1, or not our null value. And the same with 0.55 to 0.89. The two at the bottom are ranges that overlap the middle of the scale, that is, they include the value 1, and so would be considered not significant, because within our 95% confidence interval, the value of 1, which is our null value, meaning that the groups were the same, is included in that value, either from 2.5 on a negative to up to 4.0 is covering the range of for a negative number to a positive number, which means that it's going to cross the value of 0, and it also crosses the value of 1 in this case. So that would not be significant. The next one down, 0.3 to 3.0, also includes all positive values, but one is below the value of 1 and the other is above the value of 1. So we know that that one also is not significant. So any one of those three things have to be stated and true in order for a particular statistic to be considered statistically significant.